Now the second part is the property in the form of analytical form. What is the analytical form? Z is equals to a plus iota b. Like algebra, we have some rules and regulation here also. There is the first form is conjugate of a complex number. Let Z be a complex number, that is a plus iota b. Conjugate, we can say Z bar is equals to conjugate. Understood? Z bar, we use bar sign to represent conjugate, and this Z bar is equals to nothing but a minus iota b. Very easy. Example, 4 plus 5 iota. What is the conjugate? Z is equal to 4 plus 5 iota. So what is Z bar? That is 4 minus 5 iota. Z is equals to 4 minus 7 iota. We can use another also, 8 minus 7 iota. What is the Z conjugate? Means 8 plus 7 iota. Just simply change the sign. What? Minus 8 minus 9 iota. What is the conjugate? We cannot change sign of this number. We should only change the sign of that number. So minus 8 plus 9 iota. Understood? This means conjugate of a complex number. Very easy. Now the second property is equality. We can face equality of a complex number. Means in real number, the only thing to equality means 5 is equals to 5. Fixed number. But here, if you say a plus iota b, a1 plus iota b1 is equals to a2 plus iota b2, this implies that if you say equality to equal complex number, this implies that a1 is equals to a2 and b1 is equals to b2. Only then it can equal. Means example, we should write 4 plus 5 iota is equals to 4 plus 5 iota. Means here 4 is equals to 4, 5 is equals to 5. They should be equal, otherwise they are not equal. Understood? Two property, conjugate of a complex number, equality of a complex number. Now second property or third property, addition. Z1 plus Z2. Let us assume Z1 is equals to a plus a1 plus iota b1 and Z2 is equals to a2 plus iota b2. We have to add it. We can write after provement, means after a small problem. So if I can say that, if I say Z1 plus Z2, it means a1 plus iota b1 plus a2 plus iota b2. Understood? And real part is always add with real part. Imaginary part is always add with imaginary part. So we can write a1 plus a2 because both are real, and iota b1 plus iota b2 both are imaginary. So a1 plus a2 we can separate it and we can take iota as a common and we can write b1 plus b2. Now this become a formula. Then z1 plus z2 is equals to a1 plus a2 plus iota b1 plus b2. Give me an example. What is the example? Z is equals to 4 plus 5 iota and z1, or z2 is equals to 9 plus 3 iota. We have to add simple addition. What we add? 4 with 9. That gives 4 plus 9. Real to real. And 5 plus 3. 8 iota. Understood? Now it becomes, 5 plus 3 iota. Then it becomes 13 plus 8 iota. Understood? Any problem? Now we can take another example also. Example, Z1 is equals to 9 minus 3 iota minus 6 iota, or Z2 is equals to 7 plus 2 iota. Now we have to minus Z1 plus Z2. It is equals to 9 plus 7, real part to real part, and plus what is this part here? Minus 6 iota, minus 6 or plus 2 iota. We have to use sign also. That become 16 and plus minus 4 iota, and that becomes 16 minus 4 iota. Understood? Very easy sum. Now for same thing is subtraction. What? If you see subtraction, fourth very written, Z1 is equals to Z1 minus Z2. That becomes A1 plus iota B1 minus A2 plus iota B2. That gives the result A1 plus iota B1 minus A2 minus iota B2. A1 minus A2 plus iota B1 minus B2. Iota is a common, that gives the result. So if you talk about this thing, subtraction, that becomes A1 minus A2 plus iota B1 minus B2. Understood? So in plus you have to add real with real, imaginary with imaginary. In subtraction you have to add with real, you have to subtract real with real, imaginary with imaginary. Understood? Now you have to be very careful in multiplication of complex number. First I give you the formula how it gets. Z1 times Z2 is equals to, now Z1 is equals to A1 plus iota B1 and Z2 is equals to A2 plus iota B2. Understood? Now if we have to multiply this, Z1 multiply Z2, then we have to multiply A1 plus iota B1 with A2 plus iota B2. And you know this multiplication. So first we have to multiply A1 with A2. This gives us A1, A2. Then after we have to multiply A1 by iota B1. The A1 times iota B2. We just write as it is in the question. The third term is iota B1 to A2. So iota B1, A2. Problem? And now the fourth one is iota B1 multiply iota B2. Iota B1 multiply iota B2. Now it is A1, A2. And now we can serialize this. Iota A1, B2. Iota A2, B1. And iota multiply iota. Iota square. Iota square B1 and B2. Now is equals to A1, A2 and iota square become minus 1. We have already learned it that iota square is equals to minus 1. So it become minus B1, B2. Now this or this becomes the real part. So we can add or subtract real part with real part, and now this becomes imaginary part. So we have to attach imaginary part with imaginary part. Understood? Iota, we can take iota as common. So what is the formula here? A1, A2 minus B1, B2. And plus iota A1 B2 plus A2 B1. Understood? Now example, Z1 is equals to 4 plus 5 iota and Z2 is equals to 3 plus 7 iota. Now here what is the value of A1, A2? You know everything. Now you have to multiply Z1 and Z2. According to this, A1, A2, 4 3 are 12, minus B1, B2, 5 7 are 35. So minus 35 plus iota, iota a1 b2, a1 b2, a1 b2, 4 7 28, and plus, here there is plus a2 b1, a2 b1, oh sorry, a2 b1, 3 or 5, 15. Now the answer is 12 minus 35, 3, 23, minus 23 na? And plus iota 43, that is equal to minus 23 plus 43 iota. Understood? This is the formula. But where it come from? It comes from multiplying this to with the distributive law. Understood? So you have to memorize this formula. If you don't understand this, you have to memorize each and everything. But if you understand this, and whenever at some instance of time you can, if you can forward this formula, then there is no problem. You have to use this distributive law. Understood? Write it down. Now the division portion. For division, you have to understand one thing: rationalization. You know rationalization? If you don't know, there is no very big problem. In class 10 or 11, we have to understand rationalization. Means 1 by root 2, we have to rationalize it. Then how can we rationalize? We rationalize it, just multiply root 2 with root 2. That gives the result root 2 by 2. So what is the actual mean of rationalization? If we convert denominator into a rational number, if we convert denominator into a rational number by any means, by any formula, by any multiplication, division, that is known as rationalization. Why we have to convert denominator into rational number? Because if denominator is other than rational number, then it does not make any sense. If you let us assume 5 by 4, it means 3 by 4. It means you have total 4 and you have to divide 3 out of 4. But if anyone say 1 by root 2, since root 2 is irrational number, there is no any fixed number, then how can you relate this? So denominator should be a rational number always. And if there is other number except rational number, we have to convert this number into rational number, and this process is known as rationalization. Understood? So if anyone take let us say 1 by 4 plus 5 iota. This is the form of denominator. Now this part become what? Complex number. And if denominator is complex number, that means it does not make any sense. How can you divide this number? So we have to convert this complex number into a rational number. How can we convert it? So we convert it by the process of rationalization. 4 plus 5 iota, we should multiply it 4 minus 5 iota. First see 4 minus 5 iota with both sides. Okay? Then it becomes 4 minus 5 iota, and now 4 plus 5 iota, 4 minus 5 iota. We have to multiply these two numbers. So 4 16. 4 multiply 5 iota minus 20 iota. 5 multiply 5 iota plus 20 iota, and plus 5 iota minus 5 iota. 5 5 ja 20, plus minus what? Minus 5 25 iota square. That gives result 4 minus 5 iota by 16 minus 20 plus 20. Cancel. Minus, it gives the iota square minus. So minus minus plus is equal to 25. Now 4 minus 5 iota by 41. Now look very carefully. In this question, the denominator is Denominator is which number? Complex number. Now the denominator become rational number. So it is known as rationalization. Understood? If we understand rationalization, then we easily understand division. Otherwise, we cannot understand the division. Why? Because if I write Z1 divided by Z2, it is nothing but the Z1 multiply 1 by Z2. Sorry, 1 by Z2. And 1 by Z2 means what? From here, means it is a part of, we have to rationalize 1 by Z2. And it is written as Z1 multiply Z2 inverse. 1 by Z2 is also written as Z2 inverse because 1 by A is written as A inverse. Understood? This is the process of division. And this is example. For division, you have to rationalize one term, and after that you have to multiply it by rationalization. So here you give a formula. What is the formula? Z1 by Z2 is nothing but Z1 multiply Z2 inverse. Any problem here? No. Write it down. There is an example. We have already discussed some difference, multiplication and division of complex number. Now you have a clear idea about the how complex number can be added, how complex number is subtracted. This is a very basic question. Now the property is that addition for complex number, addition and multiplication follow some property. The first property commutative, first property closure property, closure. We can discuss one by one. The second property commutative law. The third one associative. Fourth one identity inverse. Identity, and fifth one inverse. Same closure property, commutative property, associative property, identity inverse. Means in addition of complex number, you find closure property, you find commutative property, you find associative property, you find identity, and you find inverse. Can you write this or not? Yes. Where?
No, I will do it for number system.
Number system. Okay. So first we discuss the property, and after that we can give the examples of that. So the first property, it is applicable in same as closure, commutative. So for first closure property, what is the mean of closure property? It is very simple. If A belongs to complex number, let us assume complex number is equals to C. Complex number we denote C dash. Okay. So A belongs to, or we can say Z1 belongs to complex number, and Z2 belongs to complex number. Imply that Z1 plus Z2 belongs to that complex number. Means if I add both number, it should also always belongs to a complex number, and it also, if we multiply that, it should also belongs to a complex number. But it is not applicable in subtraction and addition in some instance. So we do not include subtraction and multiplication here. Sorry, subtraction and division here. Understood? Now the second property, commutative. Commutative property say if Z1 is equals to A plus, we can give example, 4 plus 5 iota, and Z2 is equals to 5 plus 3 iota, then if I add Z1 plus Z2 or Z2 plus Z1, it gives the same result. We can check 4 plus 5 iota plus 5 plus 3 iota, or 5 plus 3 iota, 4 plus 5 iota. then it become 9 plus 8 iota. It also become 9 plus 8 iota. Result are same. So this is known as a commutative property. Third property, associative. Now we cannot describe this property because this is very easy. Z1, it is also in means Z1 multiply Z2 is equals to Z2 multiply Z. It is also applicable in multiplication. This is in subtraction. This is all about multiplication. Understood? Now associative property, same property, but as a law have property, same property, but there are three numbers instead of two. Z1 plus Z2 plus Z3 is equals to Z1 plus Z2 plus Z3, or Z1 multiply Z2 times Z3 is equals to Z1 multiply Z2 times Z3. Same thing, but three number. You can add in any order. If you want to add Z1 with Z2 first, then you can add. If you want to add Z2 plus Z3 first, you can add. There is no any restriction. And the second and the last thing is inverse. If you talk about inverse, what is the inverse of Z? Oh sorry, identity. If you talk about identity, means Z plus 0, it gives the result Z, or 0 plus Z, it gives the result Z. So you can say that 0 is additive identity. Because if I add any number, any complex number is 0, it does not change the value of that number. So this is called additive identity. And what about inverse? What about multiplicative inverse? Z1, yeah, Z multiply 1 is equals to Z. Yeah, 1 multiply Z is equals to Z. So by multiplying with 1, it is not changed. So 1 is considered as the multiplicative identity. Understood? Now about inverse. Sorry, I write it as inverse. Inverse. If I add Z1 minus Z2, sorry, Z minus Z, Z minus, it becomes 0. Z minus Z, it becomes 0. It is also written as Z plus minus Z. So we can say that if minus Z comes, then the whole structure is 0, whole value is 0. So we can say that minus Z is additive inverse. Understood? And if I add Z by Z, sorry, if I divide Z by Z, it becomes 1. So we can say that Z multiply Z inverse is equals to 1. So Z inverse is known as multiplicative inverse. Understood? So if I give an example, this 5 plus 4 iota. What is the additive inverse here? Additive inverse is very simple. What? Minus 5 minus 4 iota. Just change the sign. What is multiplicative inverse here? Multiplicative inverse is equals to, it is additive inverse, and 1 by 5 plus 4 iota. It is, sorry, 1 by Z. Z inverse is known as multiplicative inverse. If you say Z inverse means it cut and give the value 1. It is known as multiplicative inverse. Understood or any problem? No. These are the properties of complex number.